Okay, so we're going to go over simplifying rational functions. So rational functions are when we have essentially two functions divided by each other. Okay. Now you'll get in later into how to graph these rational functions, but the first thing we're going to do is simplifying them, because simplifying them will help us later on with graphing. And we also have to be able to state restrictions. In other words, there's going to be vertical asymptotes, which I can't remember if you've talked about yet or not. Probably not. You'll have vertical asymptotes when you go to graph stuff, and this process helps us find these things called vertical asymptotes. Okay, so what that means is we need to be able to factor the top or the numerator and denominator of this. Think of this like a large fraction. Okay, so this is a binomial, and it has a subtraction. Usually when it's a binomial, it has a subtraction sign, you kind of look for a difference of squares or difference of cubes, but that's not the case here. So what we always want to do in factoring is try to take out a common factor first. So in the very first one, what would you say could be a common factor of these two terms? Think of the coefficients. What could I divide both of them by?
Itself, 3.
Yeah, itself, yeah. Great. So we can take 3 out for sure of each of these. Okay. And what about our variables? We have x cubed and x squared. What is the largest variable we can take out of there?
X cubed.
Well, we want to not make this a negative term. Okay. So when we have this case and the bases are the same, we always take the exponent of the lowest of the two. Okay, because we don't really want to take 3 away from 2. So we'll take 2 out so that this will still say a positive variable. Okay, so in other words, we're going to take the coefficient 3 and variable x squared out of both of these, which means I'm going to divide this guy, so 3x cubed by 3x squared, and we're going to divide 3x squared by 3x squared. Okay? Do you think you can do that in head, or do you want me to work that process out?
Did you just say 3x cubed over 3x
Squared? Yeah.
Divided by 3x squared.
Minus.
Oh, minus?
Yeah. So let's write it out. We'll focus on the top to start. Okay? So instead of jumping through steps, I'm actually going to focus on each part. So let's focus on the first part when we're doing that. We're going to factor the first part. So we have 3x cubed. This is the top. Okay? Minus 3x squared. We said we could take the common factor of 3x squared out of both of these. Okay? So in other words, the 3x squared doesn't disappear. It comes to the outside of a pair of brackets, or one set of brackets in this case. Okay, that's our common factor. And when we divide the two of them, whatever's left over becomes our first term and our second term. Okay? So we have 3x cubed divided by 3x squared. Well, the 3's are going to cancel out. They essentially become a one term. And when we're subtracting exponents, we have x cubed divided by x squared. Well, what we're going to be left with is 3 minus 2 in terms of the exponents. We'll have x to the power of 1. So in other words, what's left over is just x to the power of 1. Okay? So that would be the first term. The second term, 3x squared divided by 3x squared. Well, since it's the exact same, do you know what's left over in the end?
Nothing.
Not nothing. There is a term. Think of it like, what would 5 divided by 5 be?
Oh,
1. So what's left over here is also 1. Okay? So that's what's left over on top. We have 3x squared on the outside and x minus 1 in brackets. So that would be the factor form of the first part of this equation. Okay? So let's continue with this equation. I'm going to write it. So the new numerator would be 3x squared, x minus 1. We factored the top part. Okay? And then what we'll do is we're going to try to relate these. Okay? So, in other words, that was the top part. We just factored it, and that's our new answer, the factored form of it. We're now going to do the bottom part, okay, which is read as 8x cubed minus 12x squared plus 4x, okay? Well, we're going to focus on that and factor that part now, okay? So we've broken this almost into two questions that we have to factor. So factoring becomes very important. We have to be pretty proficient with it at this point, okay? So we'll do this part, in green here. We're now going to factor this part of the equation. So we take 8, you know what, I'll do it in green, so it kind of corresponds. 8x cubed minus 12x squared plus 4x. Well, first thing we always do is look for a common factor. Can we take a common factor out of this? What would be a common coefficient of these terms?
2.
2. There's even a larger one we could take.
4.
4, yeah. We could definitely take 4 out of all of these. So when we do the Talmud factoring, we're going to divide each of them for sure by 4. Okay, so for sure by 4. And what exponent are we going to divide each of these by? Because there is an exponent in each of them. Well, what to the power of, what did you say?
1.
1, that's right. Why did you choose 1?
Because 1 goes into all of them.
Yeah, 1 goes in. It's also the lowest, right? There's one that's cubed, one that's squared. This is technically to the power of 1. So we have to go with the lowest one. So our common factor is 4x. So we take 4x outside the bracket. And inside the bracket, we're going to divide each of these, 1, 2, 3, to have what our 3 terms inside the bracket are going to be left. So 8x cubed divided by 4x. Well, what's 8 divided by 4?
2.
2. And x cubed divided by x?
2.
X to the power of 2. Good. Now this says negative 12 divided by 4.
Negative 3.
Good. X squared divided by x?
X 1.
Yeah, we don't technically have to write the 1 for the exponent, but that's 100% right. We'll write it in for you. And 4x power of 1 divided by 4x to the power of 1.
1.
1, that's right. So now here's the bottom part of our equation. Okay. Now technically I'm actually not done there. Because this bracket is a trinomial. There are 3 terms. We can factor this even farther. So we're going to go about doing that. I'm not sure which style you remember. Are you familiar with finding the factors of the first term and the factors of the last term?
You mean multiplying them together?
Yeah, to find the middle one here? Okay, so you're okay with that? Okay, so then when we go across here, 2x times 1 would be 2x, 1x times 1 would be 1x. And in order for them to add to 3, they both have to be negative. So in other words, this number 1 needs to be negative. Does that make sense? Okay, so when we go to put it in brackets, we don't forget our common factor. It's still around, 4x. One of these will be the first term, 2x. And the other will be the other first term, which will be our 1x. And the negative ones, well, because they're the same, we can kind of put them in either bracket. If they were different terms, then it would have become a little more important. So this is the factored form of what we originally started with. We have our 4x times 2x minus 1 times x minus 1. So now we're going to rewrite the entire question, but in its factored form. So we're probably going to zoom out a little here. Okay. Now in our factored form, I can zoom in a bit from that. In our factored form, our top part said 3x squared times x minus 1. Okay.
So if I did FOIL to check it, would it come up?
Yeah, as what's exactly there, the highlighted part. Okay. And we'll do the page width because I can definitely see from here. So that's the top part in factor form. And the bottom part in factor form is 4x times 2x minus 1 times x minus 1. So we've simplified this. We've factored everything. Okay, and we'll highlight them just to draw a reference. This was the top. We factored the top. We did that kind of in yellow. And we did this in green. Okay, so that's the bottom. But now, we can simplify this farther, but before we go any farther, once we're in our factored form, there's something very important we have to do, and it refers to the denominator, the bottom part of this, okay? There's an idea that you cannot divide a number by 0, okay? You can divide 0 by numbers. For instance, 0 divided by 5 would just be 0 itself, but we can't vice versa that. We can't go 5 divided by 0. If you were to type it into your calculator would just tell you that you've reached an error, okay? It's something we don't do in math because it technically would be an infinite number, okay? So in other words, we can never get 0 on the bottom of this equation. None of these terms, because there's technically, look at them as 3 multiplied by each other, none of them can be 0. Because if one of them is 0, when we go to multiply it, everything's going to be 0. So we have to solve for the terms that would make them 0, okay? So we're going to split these 3. 1, 2, 3. And we're going to set each of them equal to 0 to solve for what we don't want terms to be. So in one case, we have 4x equals 0. In another case, we have 2x minus 1 equals 0. And in the final case, we have x minus 1 equals 0. We're going to solve for x in all of these cases. In the first one, we would divide both sides by 4. X cannot equal, so we say this, x cannot equal what number? What's 0 divided by 4?
Oh, 0.
Yep. In this case here, we move the 1 to the other side, so we get 2x is equal to 0 plus 1, which is 1. And then to isolate the x, we divide it by 2. X cannot equal what term? A half. Good. And finally, when we move this 1 over, x cannot equal what?
1.
Positive 1. Good. So that's important. We're going to kind of put those as a side note. Those three terms are what's called restrictions because we can't divide by 0. So what we would say is x cannot equal 0, a half, and 1. Okay? But we're not done. I want you to very carefully look at this. Are any of the brackets on the top and the bottom the same?
X and minus 1.
X minus 1. So these two, x minus 1 and x minus 1, think of them as, let's say this number was 5 and this number is 5. Well, we could divide them by each other. They would cancel out. So we can cancel out our x minus 1 and our x minus 1 here. Okay? So they did want us to simplify. We factored, and now we do need to simplify. So we have, right in black. Yeah, I'm going to write this all out one more time, and then we're going to simplify as a group. Okay? Divided by 4x, 2x minus 1, and x minus 1. Okay? Like we said, we need to simplify. Well, x minus 1 and x minus 1 are on top, so we can create a 1. Technically, it creates the number 1, but we usually call it canceling out. Okay? 3 and 4, they don't really do anything for us. We can't really simplify them. It'll become some decimal, which we don't want. Now, x squared and x, I can simplify that. What would x squared divided by x be? 1. It would just be x to the power of 1. And that x to the power of 1 would stay on top. So think of it like we've canceled the guy out on the bottom, and this goes to the power of 1 when we simplify. So now on top we have 3 x to the power of 1, okay, divided by, and on the bottom all we have are 4. Technically the 4 is still there. And then 2x minus 1. So this would be the simplest form, and we'd also have to state our restrictions that x cannot equal, which we said before, 0, a half, and 1. Okay? Quite a bit of work. A lot of factoring. Once we get a hang of the factoring, it's pretty simple. We just have to state zeros, restrictions, and then simplify the question from there. Okay? But very important that we're able to recognize all of that.